Our next presentation is about aquatic toxicity testing. Say that 10 times fast. This presentation will introduce foundational knowledge of aquatic toxicity testing, covering terminology, test designs, collection requirements, and sample volumes. So our first speaker is Kim Wills, who's the lab director and CEO of New England Bioassay. She's the proud owner of this lab, a small woman-owned business. Over 20 years of lab and management experience, responsible for overseeing day-to-day business operations of NEB. She utilizes a collaborative leadership style that assists in making business decisions, maintaining the organization's core values, and setting goals for the company as a team. Fun facts about Ms. Wills: she's an avid runner, and though she's not a great skier, which maybe you're just being hard on yourself, I bet you're really good at skiing. It's a good family activity.
All right. Well, thank you for having me today. I'm a little bit of an introvert, so public speaking is not my thing. But I'm going to do the best I can because I am a wealth of knowledge on this topic. So a little bit about what we're going to talk about today. A little bit about NEB and our laboratory quality assurance, quality control, and aquatic toxicity facts about the test species that we use and why we use them, and aquatic toxicity test setups such as acute and chronic. Those are the most common types of tests. A little bit about what we do with data analysis, and then sample collection, sample volumes, and what you can do if your sample fails, and some of the other testing that we do here at NEB. So a little bit about us. We were established in 1986 in the basement of a consulting firm, and we've moved out of there. We are now in Manchester, Connecticut, in a lab that's about 5,000 square feet, and we are now, as of February 1st, 2020, about 6 weeks before COVID hit, we became an independent, woman-owned small business separating from a larger consulting firm. We are currently staffed 7 days a week to meet the testing needs and requirements of our clients. Some of our service areas, we do most of our testing in Connecticut and Massachusetts is where we do most of our testing, but we also do New Hampshire, Maine, Vermont, New York, and New Jersey. And we also do testing in Alabama. We have a diverse client base. A lot of our clients are municipalities, industrial facilities, utilities, power plants, consulting firms, and analytical laboratories. A little bit about laboratory quality assurance and quality control. We've been a participant in the DMRQA study program since 1991. We are currently accredited by the National Environmental Accreditation Program through New Hampshire and New York. So in order to do testing in those states, we need to have accreditation. Even though we do testing in other states, they don't require this certification. We're also certified in the state of New Jersey. We also have an approved quality assurance program with the Army Corps of Engineers, and we do monthly ref talks on all of our test species that we have in-house and other species that we get from the supplier. Okay. For quality assurance and quality control, also for part of the accreditation programs that we're in, we have to have standard we have to have SOPs, and we also have a comprehensive training program. Every lab tech has to have a training log, and in order to do any of the analysis on their own, they have to be signed off by a supervisor. We have logbooks for calibration and culture logs, but we have pretty much logbooks for everything that we do in the lab because traceability is very important. And when the lab reports go out, they are reviewed by 3 qualified lab managers. So one thing that we implemented about 8 years ago or so, we started using tablets in the lab, which has been a great addition. This helps with avoiding transcription errors, it decreases report prep time, and it utilizes spreadsheets and capabilities such as automatically calculated formulas and autofills repetitive information, and it's also environmentally friendly. So some facts about aquatic toxicity testing. It's also referred to as whole effluent toxicity testing and also bioassay. It plays an important role in the NPDES wastewater treatment program. Unlike any other NPDES requirement, it utilizes live organisms. It measures the combined effect of pollutants that cannot be determined by a chemical-specific evaluation. So the test species that we use for testing, most NPDES permits require 2 testing organisms used for, most require 2 organisms for aquatic toxicity testing, usually a vertebrate and an invertebrate. The sensitivity to each of these, to the individual pollutions are found in effluents varies between both testing organisms. Testing organisms are species which are easily cultured and readily available year-round. NEB cultures the following freshwater species. So if you have aquatic toxicity testing in your permit, these are common species that are used for testing. The fathead minnow, for chronic tests, they have to be less than 24 hours old when we load them into the test. And for acute tests, they have to be 1 to 14 days old. And then for the Daphnia, we have the Cereodaphnia, Daphnia magna, and Daphnia pulex. The Cereodaphnia are common organisms used for chronic toxicity testing, where we measure not just survival, but also reproduction. And then the Daphnia magna and Daphnia pulex are usually used in acute testing. Some other freshwater species that we do culture in-house at NEB is the amphipod Hyalella azteca, and the midge larvae, Chironomus dilutus, and the green algae. Saltwater species that we culture in-house, the mysid shrimp. These are used for both acute and chronic testing. So for chronic testing, they have to be 7 days. And at the end of the test, we're looking at fecundity. And then for acute tests, they have to be 1 to 5 days old. We also culture the amphipod Leptochirus, and we use brine shrimp. Other organisms that are maintained but we use for testing, sea urchin. There's a fertilization test that we do for that has fertilization is the endpoint, and then inland silversides are a common acute and chronic, and sheepheads we use for acute and chronic testing. We also use redworms and trout for certain tests. So we have 2 or 3 different testing rooms. We have what's called the acute room, and it's kept at 20 degrees Celsius, and most Connecticut acute tests run at 20 degrees Celsius. We also have New Jersey tests, acute tests also run at 20 degrees Celsius as well. So those go in that testing room. And then we have the chronic room, which is at 25 degrees Celsius. Most of the chronic tests that we do in Connecticut and outside of Connecticut are run at 25 degrees Celsius. And then we also have the sediment room, which is mostly maintained at 23 degrees, but it can vary depending on the type of test that we're setting up. So one of the type of tests that we do, and it's pretty common in Connecticut, is a screening test, also called a pass-fail. It's the sample, which is typically the effluent, and the control that are tested at one single concentration. So there's no dilutions for this test, and it can vary. It can be run for 2 to 4 days, but it can also be used as a chronic test as well. Another type of acute test is a definitive test, and the effluent is diluted into various concentrations, and the test run concurrently with a control. Typically, the effluent dilutions are 6.25, 12.5, 50, and 100% concentrations, but we've seen 1% and 99%, depends on your permit, as far as the dilutions go. Effluent is typically diluted with either your receiving water, or it could also be diluted with laboratory control water, which is also run independently as a control. So for acute tests, we're measuring the short-term effect induced by exposure by the effluent. So for the aquatic animals, this usually refers to continuous exposure in the effluent for short periods of time, up to 4 days. Tests are typically 48 to 96 hours, and usually one sampling event is required. So the endpoints for aquatic toxicity testing for acute tests. So for a pass-fail, it needs to have 90% or greater in that 100% effluent to pass. If it doesn't pass, retesting is typically required. For definitive, the LC50 is the endpoint, and also the acute no observable effect concentration. So the LC50 is where 50% of the organisms die. So if you have 100% survival, it's reported as greater than 100%. And then for the NOAC, if you have 100% survival, your NOEC would be 100%. Some of the advantages of acute testing: it's less expensive, it's less time consuming than the chronic tests. The endpoints are easier to measure because what's dead is dead. Some of the disadvantages is it indicates only lethal concentration. Sublethal effects such as reproduction, inhibition, or slow growth development are not measured. Only the effects of fast-acting chemicals are exhibited. So for the chronic toxicity testing, we're measuring the effect induced by relatively long-term exposure. The chronic test is typically 7 days, and there's three sampling events over 48 hours that are required for the chronic toxicity test. And what we're looking for is sublethal endpoints. So some of the endpoints for the chronic toxicity testing, the CONEC, the chronic no observable effect concentration. So it's the highest concentration which the effluent or the toxicity in a chronic bioassay that is not caused by a statistically different from the control. And then the LOEC, which is the lowest observable effect concentration, where the effluent or the toxicity in the chronic, the lowest concentration where the effluent and toxicity in the chronic bioassay that's caused adverse, statistically different than the control. And then the inhibition concentration, typically we run an IC25, and this is the point estimate of the concentration which would have caused a given % reduction in biological measurement, such as reproduction or growth. So for chronic testing, some of the advantages are it's more sensitive than the acute tests. It assesses parameters other than mortality, and it may reflect more real world. Some of the disadvantages is it is more costly, and it is more time consuming than the acute test. So for data analysis, we need to have a high control survival. So for acute test, we need 90% survival in the controls. And then for the chronic test, we need 80% for the controls. If they don't meet that criteria, the test typically needs to be retested. For statistical, we use a statistical program called CETAS to run and determine the endpoints that follows the EPA flowcharts for analysis. And a comprehensive report is generated and uploaded to our website portal. Each client has access to their own personal dashboard at any time. So I have an example here of an acute data set. So you can see on the left-hand side is the effluent percentage concentration. So you have the control, 6.25, 12.5, 25, 50, and the 100%. And then survival for the control is 100%. The 6.25 has 100%. The 12.5 has 100%, and then the 25 has 50%, and the 50 and the 100 have 0% survival. So where 50% of the where 50% of the test organisms died is in the 25% effluent, so therefore the LC50 is 25%. And then here's another example of an acute data set where we have the same test concentrations, different survival. The concentration where 50% of the organisms die is between 50 and 100%. So the statistical analysis used to predict the concentration, the LC50 in this case is 61.6, and the NOEL would be 25%. So we have now an example of chronic data set. We have on the left-hand side, the only difference between the two data sets is the control survival. The control survival on the left-hand side is 100%, and the control survival on the right-hand side is 80%. So the chronic stats are based on comparison against the control. This ensures hardiness of the organisms, and it takes into account two identical data sets, which will result in different NOEC values based on how well they perform. So on the left-hand side, we have that data set, the endpoint, or the NOEC is 12.5%, and then on the right-hand side, the NOEC is 50%. So sample collection, the permit will determine whether you have to take a composite or a grab sample. In most cases, it's a 24-hour composite sample. Temperature preservation is required. If we receive a sample greater than 6 degrees Celsius, it may be considered invalid and retesting may be required. So it's important to refrigerate or ice your sample immediately upon collection. And a chain of custody with the date, time, and sampling when it occurred for aquatic toxicity is also required. The hold time is only 36 hours, so we need to know when it was collected, when it arrives at the lab. Testing volumes are based on the number of test concentrations, the number of replicates per concentration, the type of test. Saltwater does require higher volumes. If your test has to be renewed, or if old sample has to be removed and fresh sample is added, and how many days your test runs for. So for screening test, the pass-fail, typically it's one or 2.5 gallons. And then for the saltwater, mysid, site, or Menidia, it's 2.5 gallons. And for definitive test, we require, for the freshwater, Daphne and fish, 1 to 2.5 gallons. And then for the saltwater, also 2.5, same as the screening test, it's 2.5 gallons. So for the chronic tests, this is the 3-day sampling event. For a freshwater cerio and fish, or fathead minnow test, with a typical 5 effluent concentrations, sample number 1 would need 2.5 gallons of effluent and 5 gallons of receiving water for sample number 1. Typically, these are sampled Monday, Wednesday, Friday. So sample number 1 would be Monday sample, Wednesday sample would be number 2, and that would be the same volumes as sample number 1. And then for the third sample, which would be your Friday sample, has to go for another day, so we require more testing volume, or more sample volume. 5 gallons of effluent and 5.5 gallons of receiving water. So for saltwater, we do require higher volumes for these type of tests because the test volumes require more. So again, Monday, Wednesday, Friday would be sample 1, 2, and 3. We need 5 gallons of effluent for sample number 1 and 10 gallons for the receiving water. And then for sample 3, we require more because again, it goes for the extra day, so it's 7.5 gallons of effluent and 15 gallons of receiving water. So what can you do if your sample does fail? Typically, especially if your sample hasn't failed in the past, We tell our clients to graph historical chemical analysis that usually coincide with the aquatic toxicity testing to see if anything's changed, but also take a look at various sources within the discharge and look for changes in your processes. Were there any cleaning products, new chemicals added? And then when all else fails, if you need to, we can do what's called a toxicity identification evaluation. So we do several different manipulations, and we can sometimes pinpoint what may be causing the toxicity in your sample. And then some of the other testing that NEB performs, we do sediment toxicity, soil toxicity, and product testing. So for the sediment toxicity, we do both fresh and salt water. We do 10-day, 28-day, 42-day durations. And we also do 10-day and 20-day for the chironomids. Here we go. Soil toxicity testing. We perform earthworm testing, both survival and bioaccumulation testing. We're also, we do have an approved LQAP with the Army Corps of Engineers, and we've seen quite a bit of uptick of doing this type of testing in Connecticut. This requires 48 to 96 hour water column testing with the sea urchins and mysids and Menidia. And it also requires a 10-day sediment test with leptochirus and mysids. Other specialty testing that we can perform, biological assessments for new processes and products. So like on the SDS sheets, sometimes there's ecological data on there. We can perform some of those depending on what the chemical is. We also do water accommodating fractions and water effect ratio testing. And that's it. I don't know if anybody has any questions. Yes. Yes.
So Kim, could you explain, like with the lethal concentration limit, why does that happen at that dilution, whether it's between 25 or 50%?
Sure. So it's calculating where it's estimating where it's going to be 50% of the mortality. If it's not, that's how the statistics come out. We do follow the statistical program. So when we plug in the numbers, that's where it's estimating it to be. But when it's clear cut, like that first example, so it's where 50% of the organisms die is where you get that LC50 number. Sorry.
Right. So and you're diluting that with the receiving water.
Right, so it depends on the test. I didn't actually go into sampling the receiving water. So for chronic tests, receiving water is typically collected, and that's usually upstream from your discharge. But it can also be diluted with laboratory synthetic water as well. So it depends what type of test it is. That's okay.
So are the species experiencing mortality because of the lack of oxygen, or?
It's usually something in the sample.
Okay, so it's going to be
Yeah,
something.
something in the discharge.
Right.